Okay. You can turn it in with your name on it. Alright, go. So let's go through this. 1, by Friday, you need to have these percentages memorized. Okay? So what are the middle two? 34. The next number, 13.5. The next one, 2.35. And then that last little outlier, 0.15. You need to have those numbers memorized. Okay? We'll just put it right there with your name on it. Is your name on it? Yeah. Okay. 2. Those numbers, if you just slap them on a normal curve, that's going to help you answer any questions from normal distribution. It's that simple. Then the next thing you're going to do is, based on each new problem, you're going to put what? Right smack dab in the middle of that curve. You're going to put your mean, your average. And then going left and going right, you're going to subtract and add your standard deviation. And what did I liken it to in the video? It's a lot like margin of error. It's just real simple. You add it and subtract it. So it's very similar. It's just that you're going to have 3 in both directions. 3 standard deviations. Okay? Now, I went ahead on the homework. I did number 7 in red, but I actually did number 9 in blue. And we're going to come back up to it. That way you don't have to redraw these curves every time. Okay? So I want you guys to help me out with these. And if there's any struggle, we'll go back through them. But I want to try to make it as far as we can today. And today's a lot of calculator work. Okay? So first, what'd you get for the percent between 67 and 85? 99.7. And sure enough, this was 3 standard deviations. So you could have either found them and you could have added up everything in between, or you could have thought, hey, that's 3 standard deviations, so that's 99.7%. B, though, they wanted to know the probability that a score is no more than 79. So if I find 79 right here, what does no more than that mean? No more, does that mean that that's the highest it could be, or that's the lowest? That's the highest. So we're talking about all the values to the left. So that includes 34, 34, 13.5, 2.35, and 0.15. Or you could have thought about it this way. From the middle down is how much? 50%. Plus 34% is 84. So that's 84%. Okay? And then the last problem, a little different the way it's asked, isn't it? It doesn't say what percent. It doesn't say what probability. It says about how many scores fell between 1 standard deviation from the mean. Well, 1 standard deviation from the mean is what percentage? It's 68%. But they don't want to know what the percent is. They want to know how many. So what do we do with 68%? That's right. So we take 0.68, that's 68%, and we multiply that by the total. And how many golf scores were there here? So 0.68 times 125. And that would have been 85 scores. So if you put 68% on the test on Friday, you get it right or wrong? You get it wrong. Because you're not answering the question that they're asking. Now maybe you get it partially wrong, but you get it wrong. The answer is 85. Okay? Questions about that? Feel good? All right, then move on to the next problem. This one was a little tricky in that they told us the mean as 5 hours, and they told us the standard deviation is 15 minutes. So as I went through and labeled, I'm like, okay, 5 hours, 15 minutes, 5 hours, 30 minutes, 5 hours, 45 minutes. And then to the left, I got 4 hours, 45 minutes, 4 hours, 30 minutes, 4 hours, and 15 minutes. But then if you look at B, do they even ask it in that format? No. So that was the little trick to this particular problem. So I had to be able to associate minutes to decimals. So for example, 5 hours and 15 minutes would be what as a decimal? 5.25. Because a quarter of an hour compared to a quarter of a decimal, 15 minutes is 0.25. So, for example, 4.5 is equivalent to 4 hours and 30 minutes. So I went ahead and I just made those changes below it just because I saw it in the problem and I didn't want to have anything tricking me. So as you can see here, 4 hours and 45 minutes is 4.75. Y'all know that, right? 4 hours and 30 minutes, 4.5. 4 hours and 15 minutes, 4.25. So I made that change right off the bat. So when I go to answer either question, I'm not going to be tricked. So A, what is the percent that the phones have a battery life of at least 4 hours and 45 minutes? That's right here. And what does at least mean? That's the lowest. So it could be from there and everything to the right. So what'd you get? 84%. 84%. Next one. What percent of the phones have a battery life of between 4.5, that's here, 4 hours and 30 minutes, and 5.25, 5 hours and 15 minutes. So we're finding between those two big red lines. So what percentage falls there? 81.5%. With me? All right, that's done. Last one. It asks what percent of phones have a battery life less than 5 hours. Well, guys, what's less than 5 hours? 50%, right? It's right smack dab in the middle. So everything this way is 50%. But also greater than 5.5 hours. So that's from here to the right. And how much is that way? Just 0.25. I'm sorry, 2.5. Said that wrong. So we got 50% one way. We got 2.5% the other. So together, that's 52.5%. Now, any questions with that one? Pretty simple, right? Now, those last two basically gave you an entire set of mean and standard deviations for one single question. So if you went and drew it, that's fine, but it's also kind of a waste of your own time when you have two really nice drawings above. So what I did was I put numbers 9's mean and standard deviation on number 7. So it told me my mean was 24 and that my standard deviation was 6. So I've got 24 and then I started adding 6 to the right. 30, 36, 42. To the left I subtracted 6. 18, 12, 6. Then I can answer any questions and I don't have to redraw anything. So I looked at number 9. Here's what it told me. If there are 60 total employees, approximately how many, not what percent, not what's the probability, how many work at least 30 hours. So at least 30 hours is right here. At least 30 hours. At least means what, guys? That's the least amount. That's the lowest amount. So I'm only looking to the right. That's 13.5 plus 2.5, which is 16%. 16%. But is 16% the answer they want? No. They want to know what is 16% of the total employees, 60. 16% of 60 employees. So I type that in my calculator, and I get 9.6. So what would I write? Approximately 10 employees. Now somebody made a point in my last class that you can't really have 0.6 employees. And I'm like, you're right. But I think in that situation, we are allowed to round up. But if you did all that work correctly, you saw that 9.6 and said, I can't have 0.6 employees, so you did 9 employees instead of 10, I would not mark it wrong because you did the work right. Okay? All right, and the last one, I did it on number 8's graph. See, 3.1 was the mean, and the standard deviation was 0.3. So I did 3.1, and then I added 3.3, 3.4, added 0.3, 3.7, 4.0. Going to the left, I subtracted 0.3, 2.8, 2.5, 2.2. So I didn't reinvent the wheel. I just used number 8's graph, and I put those new mean and standard deviations on it. Now I read the question. If there are 1,800 students enrolled at the school, approximately how many have a GPA between 2.5, here's 2.5, and 3.7, here's 3.7. Now what is that? That's 2 standard deviations, which you could remember this way. What did I say 2 standard deviations from the mean were? 1 standard deviation is 68, 2 standard deviations 95, 3 standard deviations 99.7. So that's 2 standard deviations. So some of you guys may have thought that way and thought that's 95%. Others could do what? You could add them all up. No problem. That's 13.5 plus 34 plus 34 plus 13.5. You don't have to do it that way, but both are really good. So 95%. But they didn't ask about the percent. They didn't ask about the probability. They said how many students have a GPA. So I'm going to take 95% and I'm going to multiply it by my total number of students. And that was what? So 95% of 1,800 students is going to tell me that I have approximately how many? I have approximately 1,710 students who have a GPA between 2.5 and 3.7. That's what we just answered. Okay, questions? Did you say solution? No. Oh. Pretty easy, right? Am I right? Is that easy?
Yeah.
Yeah, it is easy. So I don't foresee you guys really struggling with that, especially if you remember what numbers? 34, 13.5, 2.35, and 0.15. You're going to have the normal curve drawn for you on a review or on a quiz. You won't have to even draw it. You can just fill in those little spots with those values. 34, 13.5, 2.35, and 0.15. Got it memorized, Caleb? All right. All right, I want phones away. Those things are getting on my nerves today. I don't know why. I think I know why. Because when I'm gone and people act like they struggle with the lesson, it's because you're on your phone instead of watching the video. I know it's easy to do that, but again, that's not my fault. The lesson is not hard. It's still me teaching it. I know it's not the interaction, but it's the same delivery I would have done if I was sitting here with you guys. The only thing we don't have is the questions that you would ask. So really, the struggle comes from the focus. I'm telling you, it is. Like that probability week, you guys did pretty bad on the quiz for the most part. There were some who I know cheated off of your table mate. I could tell by the way you answered the questions. I knew that was going to happen. Also, just so you know, when you go and look at your grades and you see that really low grade on that probability quiz, because the grades overall, and some of y'all did really well, but overall the grades were so bad that I decided just to make that a homework assignment because I thought it would be a little unfair. It would drop your grades pretty bad in some cases if I made that a quiz. So I didn't. I made it a homework. It says probability quiz, but it's a homework assignment. Now, the Unit 10 test that you did take, some of you guys didn't do as well on that as maybe in the past that you would want to. So here's the rest of the week. Today, we're going to do scatter plots and regression, and we probably won't even finish it because it's just so many key presses, and we have such a limited amount of time in a class. We will barely get finished with it if we do. If we finish it, you won't have time to work on your homework assignment in class. And since you don't have these calculators at home, all of you, some of you do, I know, but since you don't all have these at home, it would be hard, since this is literally a calculator day. I mean, it really is. You'll see it. It would be hard for me to give you an assignment and say, this needs to be ready to turn in tomorrow morning. So tomorrow, you're going to have about 20 minutes in class to work on this assignment. Whether I even give it to you today or I just wait until first thing tomorrow, you'll have about 20 minutes to work on the assignment. It's a front side. It's got 4 problems on it. So it's not crazy, but it's all calculated, all. So that leaves us about 25 minutes for me to do a review. And then the very beginning of Friday, you'll take a quiz. 10 questions. Should it take you 20 minutes? Probably max. Some of you guys will be finished with it in 6 minutes. But the max it should take anyone is 20 minutes. 2 minutes a problem. Because there's a couple problems you read, and you have to say, is it observational study or experiment? Takes 2 seconds, right? Anyhow, that means there'll be a little bit of time tomorrow, okay? If you feel like your Unit 10 test really hurt your grade, I know I just entered it. That's on me. That's not your fault. If you would like to do corrections tomorrow after you're done with your statistics, or Friday, I'm sorry. If you'd like to do corrections on that Unit 10 test after we finish the statistics test, you can ask me, and I will let you, okay? If you don't ask me and you just go back to your desk and you choose, that's fine, okay? I'm not going to make you do anything. We have a very small window before grades are due, okay? This is that awkward time where we end on a Friday, we come back to school on a Monday. However, and the 9 weeks is over. Our grades, though, don't have to be entered until like Thursday. So we still have a small window next week to get some things done. So that's going to be a couple of you guys who have assignments or whatever it might be. You'll have a small window, okay? But your assignments need to be turned in on Friday of this week. And if they're not, you and I should just have a conversation. If you think you need extended time because you missed a certain amount of days, just talk to me, and we can work that out, okay? But you got to talk to me. You can't just not talk to me about it and just expect that I'm going to just collect your homework assignments next week. If you don't have a conversation with me about needing a little extension to get all your homework assignments in, then when are they due? Friday, and that's the cutoff, okay? Now, I know some of you guys missed some things, missed some days. Have a conversation with me, and I'll be willing to extend that. But if you don't have a conversation with me, I'm not going to extend it, okay? All right, so here's the deal. Today, Emily, put your phone away. Today, we are going to, you've been on it all day so far since we've been in here. You've been on it. We're going to basically use our calculator to enter data, and then we're going to use our calculator to see that data and figure out what kind of equation is this going to match up with. Then we're going to use our calculator to run that equation. Okay, you're not going to have to do it in your own brain. You're going to get to use your calculator. But you've got to be able to notice when you graph it, what kind of equation it looks like. So these are the 4 we're going to deal with. Lines, quadratics, exponential, and logarithmic. So you need to be able to look at data and say, okay, I know which one this is. So if it's a line, guys, what are my options? those points, they might be a little bit spread out like this, but overall, what will they look like? They'll look like a line. Whether they're going up or they're going down, they're going to look like a line. Okay? Is that a hard concept? Ian, put your phone away. Or it's mine the rest of the day. Okay. Where's your phone at? Okay, next. What about a quadratic? What did those look like? Yeah, they look like a U. Now, that U could be open up. So it might start by going down, but then those points would kind of start to flatten out, but then they would go back up. So maybe it looks like this. What's the other option for it to be a quadratic? Yeah, it's like inverted, right? So instead of starting going down, it starts by going up, but then at the top it starts flattening out, but then it ends up doing what? Making its way back down. That's what you would expect if it were a quadratic equation. But then we have exponential. Exponential has two different looks. One, it could start out really flat, but then all of a sudden it starts going what? It starts going up real fast, right? That would be exponential. The other option is it's coming down real fast, but it starts doing what?
Flattening out.
Flattening out. So maybe my points look kind of like that. And then I would describe logarithmic as the exact opposite of that one that we just drew. A logarithmic's going to start by going up real fast, but then what will it do? It'll start flattening out. Okay? So you're literally going to get your calculator out. You're going to visualize these graphs on that calculator and determine, hey, does this look like a line? Does it look like a quadratic? Does it look like a logarithmic? Does it look like an exponential? Everything is done with your calculator. And in all seriousness, every key press that we're going to make are in these notes. Now, I hope that you follow along with me, but they are all here, okay? They're all on here right now. So let's go through this. The first thing I would expect you to do is to reset your calculator, because somebody could have made an absolute mess of it right before you. So we're going to reset. Second plus 7, 1, 2. Ian, how many times have I said this is a calculator day? Yeah. Okay. On Thursday of last week, we did population mean and proportion, and one of that was entering data. And I told you, anytime you want to enter data in your calculator, where do you go? We're going to go to Stat, and we're going to go to Edit. And we're literally just going to enter this data that we have here on example 1. So we got 0, 4, 7, 10, 12, and 15. Now remember, these are ordered pairs. So can I just enter these any way I want? No, they've got to match up with each other. 0 has to go with what Y value? Right? It's got to. And 4 has to go with 82. You get it? You have to put these in correct order, or there will be obviously a mistake made. All right. So we've entered our data. Everybody with me? Now here's the deal. I want to see this data, right? But I can't just push graph, because graphing it graphs what's in Y equals. Did I put this in Y equals? No. So the first thing I need to do is tell my calculator I want to graph this stuff. So here's where I go. Ready? We're going to go second, Y equal, and we're going to turn our stat plot from off to on. So we're going to push enter enter. And it highlights on. Now we've told our calculator to graph this data. But look at the data, guys. You got y values that are up in the 80s. If I graph this right now, am I even going to see it? No, because my calculator's window is 10 to the left, 10 down, 10 up, and 10 right. I won't even see this stuff. So I got it. Last thing, I got to tell my calculator to see the data. So the button I hit is zoom. So push zoom. And we're going to zoom in on the data. Where did I enter the data? Where did I enter the data? In stat. So guess what we're zooming on? We're zooming on stat, number 9. Push enter, and boom. There it is. There's the data. There's the ordered pairs we entered into stat. So we graphed it, or I'm sorry, we went to stat, edit, and we entered it. Then we turned our stat plot on. Then we zoomed in on the stat. Now look at it, guys. What does that look like to y'all?
Linear.
Yes, I agree. So part A, we looked at the plot, and we determined that this is linear. So what does A or what does B say? It says find the appropriate regression equation. We want to run the equation for this data. So y'all told me it was linear. Let's go run a linear regression. So here we go. And all these key presses are right below it. We're going to go to stat. We're going to go over to calculate. And towards the bottom, here we have all of our regression equations. Guess what number 4 is? Linear. And in fact, it's in mx plus b form, which is the way we usually like it. So I'm going to run a number 4. Time out. What do y'all think number 5 is? Quadratic. We're going to use that one too, aren't we? We're not going to use cubic and quartic right now, but keep going. There's another linear. It's just not in mx plus b form. Look at 9. What is 9? ln.
Logarithmic.
That's logarithmic. And then right below that, exponential. There's the 4 we need. Exp, linear, logarithmic. And then up here, quadratic and linear. So let's run a number 4. Y'all told me it was linear. Let's run a number 4. So you just push enter a bunch until finally it spits out your equation. So here we go. Let's write it. Y equals AX. What's A? Negative 0. Let's round to what? 2 or 3 decimals? Your call. 2. So that's 0.61x. So negative 0.61x. And then B is positive 84.85. Let me go back to my paper. There you have it. That's your equation. I hope you wrote it. It gives you the equation when you run the regression. So you don't even have to memorize what the equations look like. You just fill in all the blanks. Now, what I always like to do, I always like to go back to my graphing calculator, go back to y equals, and I like to visualize this. Negative 0.61x plus 84.85 and graph it. And I like to see, did I do pretty good? Is that line that we came up with for the equation, does that look pretty good through all our points? Looks pretty good. So I feel pretty pleased with that. So the last question it asked me is, use that regression equation to predict the water temperature of the lake at 22 feet. So what do? I plug 22 in for x. So I literally go back to my calculator and I predict. I go negative 0.61 times 22 plus 84.85. Enter. And it predicted that it will be about 71.43 degrees Fahrenheit. And there you have it. We're done with example 1. We entered our data. We graphed our data. We determined what we thought it was, linear. So then we ran a linear regression equation. We wrote the equation. We checked the equation to see it matched the data pretty nicely. And then we allowed it to predict our future values. That's today. Okay? Now, there is one trick to some of these problems. Go to the back. If I have years as my x, are y'all listening? If I have years as my x and I enter those years, it skews my data pretty hard because those x values are so big and yet so close to each other. It doesn't give us a great equation. So when our years are our x value, we like to change it and do something like this. Years from, and then you find a nice spot. So look at all the data. Years from 1990 is a good spot. So when I go enter this data, what will I actually enter for 1992? I'll put a 2. For 1994, 6, 8, and 10. So, for example, on number 3, if you get ahead of me, anytime we do this, I'm going to tell you guys what I would prefer you using. That way our data is closer to each other. But for this one, if you're going to go out in front of me, let's do years from 1950. So what would I do for 1970? 80, 85, 90, and 2006. So, like that. All right, let's go back up to example 2. Ready? Let's go enter our data. I'm going to reset my whole calculator. Second, plus, 7, 1, 2. And y'all are going to talk me through my order. Go. Stat. Edit. So 2, enter. 4, enter. 6, enter. 8, enter. 10, enter. Then on the other side, 633, 793, 1100, 1771, 4696. Okay? I'll let y'all catch up. Tell me my next key presses. I got to tell my calculator to do what? Graph this stuff. So I tell it to turn the stat plot on. How? Second y equals, and we're going to turn that from off to on. But then we want to view this. And because my data is so big, what do I need to do to view this data? Zoom in on to zoom stat, number 9. Enter. And there we have it. So guys, if you look at your list, what does this look mostly like? I agree. So what are we going to run? We're going to run an exponential regression. So let's do that. Where do I go? Where do I go? Stat, but then I'm going to calculate, and I'm going to go find exp reg. All the way down here at 0, push enter a bunch until it gives me my equation, y equals a times b to the x power, and then we're going to do as good a job as we can rounding. Here's what I mean by this. The less you round, the better your equation will be. Okay? If I round to 1 decimal, that's not going to be as good a graph as if I round to 2 decimals, which is not going to be as good a graph as I round to 3 decimals. So I would recommend you find a really good spot from 2 to 3 or 4 decimals. So a, y equals a 320 point, what do y'all want to do? 28 times, what do y'all want to do here? 1.27. I would have probably done 272. I'm going to do that. You don't have to, but my graph will be a little better than yours. Like it'll fit a little better is what I mean. I didn't like, it'll fit better, okay? Exponentials change so quickly, the more you round, it hurts the actual graph. So I'm going to use 320.28 times 1.272 raised to the x power. So here I go. I'm going to go back and check it. Go to y equals 320.28 times, at the 8, times 1.272 raised to the x power. And then I'm going to graph it. Now, there's a couple problems I don't love about this. It didn't go up as steeply and quickly as I would have liked, but that's the equation it ran. So I'm going to trust it, okay? Now, last thing is predicting. It wants me to predict the closing price in 2003. Always be careful with this. What did we set our x values? Years from. So what will I be plugging in? I'll be plugging in 13. Be careful with that. Okay? A lot of times people forget that, and it gets all messed up. So we've got 320.28 times 1.272 raised to the 13th power. So with our calculations, it's going to be about $7,309. Now, just to show you, just to prove it to you guys, how many of you guys actually rounded to 1.27? That's a difference of 0.002, isn't it? But what did y'all get? What did y'all get as your total here? Elsie, what'd you get? Oh, that's really close then. I thought it was a bigger difference than that. So really, it didn't make a huge difference. 0.003 is 0.002 is pretty small. So pretty good. All right. Questions about that one? What time we got here?
20.
Okay. I don't know if we have time to do the whole thing, but let's look and see what it is. I'm going to reset. I'm going to go to Stat Edit. I'm going to enter my data real quick. 20, 30, 35, 40, 56. Then I'm going to scroll over here. We got 30. We got 35.3. We got 37.9. We got 37.2. And we got 41.5. Okay, let's graph it. So I'm going to turn my stat plot on. And then I'm going to zoom in on my stat. That's probably questionable. But if y'all were going to pick one, which one would you go with?
No, logarithmic.
Me
It says
too.
on the paper logarithmic.
Right, I would actually go with logarithmic. Because you can see how it kind of goes up and then it looks like it might flatten out. But yeah, the paper itself says logarithmic. So when it tells you what to do, you don't really have an option. Okay? All right. Tomorrow, I'm just going to give you your paper at the beginning of class unless you want it now. If you want it now, I'll go ahead and give it to you. But, yeah. But since you don't have a calculator at home, I'll just wait until tomorrow. You'll have about 20 minutes to work on your class. Now? You'll have about 20 minutes. Oh, you can say. Yeah. Here, pass it over. I had the review too.
Yeah, the Friday. You said the Friday day. Test.
Corrections?
Yeah.
Yeah.
Well,
For the unit 10.
next week.
Yeah,
I don't know what I made.
you'll have a tight little window. You too. You'll have a tight little window, but yeah.
Sorry.